Okay, so at this point, I'm going to start the lecture. Again, good evening to everyone, to those who just joined in. Um, Again, our lecture is already uploaded at the UVLE. I'll just pull it out right now. Ito yun, ano? So this is the old version, and then this is the new version, the remote learning tab. There's just additional slides. So normally, I solve the examples on a whiteboard, okay? But we do not have that right now. So I already solved the example and then put the slides there, okay? So tonight, I'll give a lecture on general methods for network analysis. Okay. Okay. So let's move on. Oops. Okay. So the outline for tonight is just give an outline for network analysis. Then we'll talk about network topology, so some definitions, some examples, and then mathematical models of networks. And then I'll talk about incidence vector and mathematical description of branches. Okay? So actually, the first few slides, puro definitions lang. Guys, kung bilibilisan ko, you have the benefit of the recording, which I will release later, and also you could just repeat that, okay, yung recording natin. Okay, so for this class, well, our main topic is load flow. So essentially, it's just circuit analysis. Okay, so we will look at the entire power system as if it's just a big circuit that we will analyze. Well, the main problem with that is, well, um, the equations that we will deal with are mostly nonlinear, okay? Or there are linear equations, but there are nonlinear equations as well. So take note that when we multiply voltage with current, the result is power, electric power. So the fact that we have that multiplication operation, okay, the equations will become nonlinear, okay? So take note that given a power system, our objective is to solve. So when we say solve the power system, we have to derive the values of all voltages, currents, power flow, losses, etc., etc. Okay, so um, so essentially, that's a very tedious task. Okay, and and it requires some advanced methods, or if not a powerful computer. Okay, so for us to arrive at the solution. Okay, anyway, so we will talk about the power network as a network in general. Okay, again, it's a group of components interconnected in a special form to accomplish a particular task. So in particular, the electric power network, its main task, the particular task that we're talking about, is the transmission of electric energy from the generators uh, to the to the load centers, okay, to us, the customers. Okay, so the components that we're talking about are these transmission distribution lines, transformers, etc., etc., etc. Okay, so we are solving a network. Okay, so in fact, everybody knows how to do that. In fact, our first electrical engineering course is circuit analysis. Okay, and what is circuit analysis? Ano ba talaga yung pinanggagalingan ng circuit analysis? Well, the main principles are the conservation of energy and the conservation uh, of, of charge. Okay, so that's where Kirchhoff's current law and Kirchhoff's voltage law comes in. Okay, syempre nandun yung ating classic na Ohm's law. Okay, don't have to elaborate on that. But essentially, Kirchhoff's current law, it's just a conservation of charge. And then Kirchhoff's voltage law, it's just a conservation of energy. Okay, so that would be these two equations, actually these three equations will be the basis of all the analysis that we will be conducting in this class. Okay. Now, the next few slides is just a procedure for power network analysis. So how do we analyze a power system? Okay. So there are four steps. Okay. So I'll go through them. And then babalikan ko na lang, ano? So the first one is physical modeling, okay? Physical modeling, and then mathematical modeling, and then selection of the reasonable numerical algorithms, and computer solution and simulation. So those are the 4 major steps, okay? So let us apply those 4 major steps to a power system, okay? So the first one, physical modeling of the network. Um, okay. So for the, hindi ko ma-reconcile yung class list natin. Bakit 33 tayo lahat dito? O dapat ano lang naman tayo? Ilan ba yung klase natin? Alam ko 32 lang tayo dapat eh. Guys, pakitingnan ninyo yung ano ha, baka may makita kayo dyan na hindi pala natin kaklase or baka twice kayong nakalog in. Okay? Anyway, just proceed. Okay? So for the physical modeling, essentially we have a physical system. Okay? The electric power system is a physical system. Okay? So we can see the wires, we can see the poles, the transformers, etc., etc. Okay? So how are we going to analyze that? Okay? So we're going to use our intuition. Okay? We're going to use an intuition, and then we will use our intuition to convert that physical model into something that is more abstract, like a mathematical model. Okay? Essentially, our objective is to derive a set of equations that we can use, that we will use to analyze the system. So here, from a physical system, something that we can see, something that we can touch, we're going to derive the mathematical expressions that we will use to describe the behavior of that system. Okay, so when we derive the physical model, it will be derived from physical concepts. Okay, we use our intuition. Okay, so one good example here is the first one, the pi equivalent model for transmission lines. So you see the transmission lines. Okay, so paano kaya natin imo-model yon? Take note that what we are solving for are the voltages and the current. So we have to derive a set of equations that will relate the voltage and equation to each other. Okay, the voltage and the currents to each other. So how are we going to model that? Um, well, to relate the voltage with the current, dapat may impedance. Okay, so when we see the pi equivalent model, so nakita natin yung pi, you know how pi looks like, diba? You know how pi looks like? I think on my next lectures, dapat may pen yata ako. Ipapakita ko na lang sa inyo yung ano. Okay? Maybe I can do that later on. Okay? A pi equivalent model. Um, um, we'll just the leg of that file. Okay? So sandali lang. Mag-experiment lang ako, guys. I don't know if this is gonna work. Okay? So when we see pi equivalent model, we know that a transmission line is usually modeled this way. I'm not sure if you're gonna see, you'll be able to see this. Hindi, kasi hindi yan nakikita, naka-blank. Okay? Tapos yung background ko, basura. Anyway, huwag na lang. Never mind. Okay. So, pi equivalent model. Okay? So you see that series component, it should be an impedance. Okay? And then we know that these transmission lines, they have capacitance. Okay, so we have parallel lines, one alongside each other. So they have capacitance between them. And then these transmission lines also has capacitance to ground. Okay, so malamang ang magandang mathematical model natin is based on a pi model wherein you have a resistance and an inductance in series. Okay, that would be the series impedance of the line. And then maybe there should be a way to represent the capacitance between the line and ground. So those are the two capacitors that we see. Kung ito yung pi, ito yung capacitor, tapos ito yung R and L. Okay? Moving on. So ngayon, may idea na tayo that the series component should be an R, a resistor, and an inductor. It's in series with an inductor. Okay? So the next is, okay, let's now derive a mathematical model for that. Okay? So since R and L siya, well, bibigyan lang natin ng value yung resistor, yung inductor, bibigyan din lang natin ng value yung capacitance. And then we will write the equations that will relate the voltage and the current in that network. Okay? Now, if we have a big network, then it will be a network made up of all those pi equivalent models. Okay? So we have different buses that are interconnected to each other. Okay? So, for example, what you can see at the bottom, for an electrical network, the model is the network equations built with the aid of graph theory. In fact, that's what we're going to do in a few minutes. Okay. Next is a selection of reasonable numerical algorithms. Okay. So now we already have a set of equations. So the task at hand is to determine the unknown variables. How do we solve for the voltages and the current? Okay. So at this point, we are now going to choose the numerical algorithm. So dito napapasok na whether you're going to use a closed form solution, you're going to solve the differential equation kahit anong mangyari, or you could use a numerical algorithm like Newton-Raphson method, or Jacobi method, or the Gauss-Seidel method, etc., etc. Okay? So when we choose the algorithm, the network characteristics should be taken into account, and we also have to consider the computational burden, memory use, difficulty in programming, convergence, efficiency, error, and stability. Okay? Later on, towards the end of the SEM, magkakaroon tayo ng lecture called Sparsity Techniques. Okay? So take note that when we solve a power system, we're going, it involves a lot of equations. Okay? Take note if we have a power system, say with 500 nodes, with 1,000 transmission lines, just imagine the amount of computation needed. Okay? So we have to find a suitable algorithm that will be able to solve that large system of equations. Okay. So after selecting the algorithm, the last part is the execution. Okay. We'll use a computer, we will write a script, a computer program, and then we will simulate. Okay. So essentially, we are now running, or we are now using the computer to find the solution for us. Okay. And we do that to verify the correctness of the model, to determine the reliability and practicality of the selected algorithm, and to analyze. Okay? Actually, yung trade bullet ito naman talaga yung gusto natin gawin. Okay? To analyze and predict the performance of the system. Okay? So the other two, syempre, importante din yan because when we see how the system behaves, and if it's not behaving as expected, doon natin makikita whether tama kaya yung model na ginamit ko, or am I using the right algorithm? Maybe it's not converging. Maybe I should be using another algorithm. Okay. Now to cut everything short, okay, we have physical modeling, meaning you have the physical system, something that you can see, something that you can perceive. Okay, we're going to convert that into a mathematical model, which is essentially a system of equations that relate the variables that we want to solve for. And then after writing all those equations, we will now choose the method so we can solve for the variables that we are looking at. And finally, we will use a computer to solve. Okay? Any questions, guys? Okay, wala naman. Sige. I'll just move on. So at this point, we will have a little bit of network graph theory. Okay, graph theory because later on we're going to use a little bit of graph theory to solve the network. Okay, so medyo magiging mathematical kung next few slides natin. Okay, so what you can see here are just some definitions. Okay, don't worry guys, kasi these definitions will come with examples that. Okay, so take note that a network, it's an interconnection of several components, and then put together, they are to deliver or they are to achieve a certain function. Okay, so that network, it can be represented by a graph, and this graph the graph has these components. Okay, it has branches, it has nodes. Okay, And then we can specify the degree of the graph, okay? The path, um, the path, we can specify paths. We can define if that graph is connected or oriented, okay? Anyway, I'll just go through this, okay? One at a time, okay? So a branch, it is an abstract of a two-terminal circuit element. So imagine a power system. So you have several buses. So yung mga buses na yun, actually siya na yung mga nodes, okay? And then between those buses, there are interconnections. It could be a transmission line, it could be a transformer. So essentially, the branches in our network are the transmission lines and transformers, okay? And then the nodes, ito yung mga buses natin, okay? I think I'll just go to the example. Okay, this is a simple example. You know? So here we have a graph. Okay, this is a graph. This is a graph with 7 branches. So the branches, these are the elements that connect the different nodes to each other. Okay. So again, we have 5 nodes. Okay. And take note that this graph, it is a connected graph. Okay. So we say that a graph is connected if there is at least one path between any 2 nodes. Okay. So what is a path? A path is a sequence of consecutively connected branches in which no nodes appear more than once. Okay, so essentially, if we can go from one node, from any node to any other node, and there's a series, a sequence of branch to get there, then it means that we have a connected graph. And this is an example of a connected graph. So what if there is um, so what if there's a node here, okay, na walang connection to any one of them, nyari dito, kung saan nasan yung pointer ko, then hindi na connected yung graph. Okay? Now, this is also an example of an oriented graph. So let's go back to the definition of oriented graph. A graph in which any of the branches has a prescribed direction. So here, we see the 7 branches, and the 7 branches, all of them has a specified direction. In fact, importante yan sa load flow or in network analysis because when we define currents, we need direction. We define current with magnitude and direction. Okay, so hindi natin sinasabi na the current in this wire is 2 amperes. Okay, we specify kung ano yung direction ng current, okay, along the wire. Okay, now, take note that in the definition of path, a path is a sequence of consecutively connected branches. So here, if we look at nodes 2 and 5, there are several paths, okay, that we can take to get there. So we can go this way, branches 1 and 7, or branches 2, 4, and 7. We can also go this way. So 2, 5, and 6. We could go 3, 5, 4, 7. So take note that there are several ways to get from node 2 to node number 5. So marami yung paths, etc. Kaya meron tayong etc. dito. Okay? Now, let us define a degree, okay? The degree of a node, take note, when we use the term degree, we are referring to a node, okay? The degree of the node is the number of branches connected to a node. So going back to this example, okay, node 1 has a degree equal to 3 kasi may 3 branches na nakabit sa kanya. Similarly, node 3 is of degree 3 and node 5 is of degree 2. The degree of node 5 is 2. Okay? Simple lang naman yan. Okay? Next. How about incidence? Incidence, parang it comes from the word incident. Okay? Parang there's an instance. Okay? So, incidence means there is a connection. Okay? There is a connection between branches and nodes. Yun lang naman yung ibig sabihin ng incidence. Okay? Let's just skip that part. Let's just use the example here. For example, if we look at node number 2, we can see that there are 3 incident branches. There are 3 branches that are connected to it. Okay? Doon natin ginagamit yung term na incidence. So, branches 1, 2, and 3, this one, and this one, they are incident to node number 2. Okay? And then similarly, okay, The nodes incident to branch 6, this is branch 6, are nodes 4 and 5. Okay? So when we use the term incidence, pwedeng sinasabi natin yung incidence ng branch to a node or ng node to a branch. Okay? Essentially, we're just saying that they are connected. Okay? From the same example, we say that branch 1 is not incident to node number 3. And node number 4 is not incident to branch number 7. Okay? So again, pag may questions, pakigamit lang yung raise hand feature natin. Okay. Now, more definitions. We have the subgraph, loop, tree, tree branch, co-tree, link, and fundamental loop. Okay? Ganito, no? But before moving on to those definitions, tingnan muna natin ito nasa taas. Okay? Again, electric power networks are modeled as connected or oriented graph. Okay? And then, when we analyze a circuit, we usually select a reference node. Diba? Parang we select a ground. Kasi when we refer to or when we have a voltage variable, that voltage is with respect to ground. Okay? So going back to this example, okay, so if this is the entire circuit, we choose one of the nodes there to be the ground. Okay, so usually, tayo, no, by convention, lagi natin pinipili yung nasa pinakang ilalim na node. Okay, so it could be node 5, it could be node number 4. Okay, actually, any one of these nodes can be the reference node. Okay, so let us define subgraph. A subgraph is just a subset of the graph. Okay, a loop is a path that starts and ends at the same node. A tree is a connected subgraph of G that contains all nodes of G and does not contain any loop. Okay, and then the branches in the tree is called, or a twig is a twig or a tree branch. If you remove the tree from the graph, you are left with a co-tree. And the branches of the co-tree is the link. Okay, and a fundamental loop is a loop in which only one branch is a loop. Parang ang daming definitions. Don't worry about that because the best way to demonstrate that is through the example. Anyway, before moving on to the example, we have a couple more terms to define. The cut set and the fundamental cut set. A cut set essentially is just a group of branches that divides the graph into two disconnected. Keyword here is disconnected subgraphs. Okay? Meaning the two subgraphs should not be connected in any way to each other. And then we define a fundamental cut set as a cut set with only one branch as a tree branch. Okay? Again, the best way to talk about this is through an example. Okay? So I'll be using the original example here. Okay? So this is our network. Okay? So same lang yung numbering natin. So it still has 5 nodes and 7 branches. Okay? And this graph, meron siyang napakaraming subgraphs. And these two are just a couple of them. Okay? So again, a subgraph is just a subset of the entire graph. So this thing here, the 3 nodes, 1, 2, 3, together with branches 1, 2, 4, it's a subgraph. Okay? These 4 nodes here, 2, 3, 4, and 5, together with branches 2, 3, 5, and 6, it's another subgraph. In fact, marami kayong pwedeng i-drawing yung subgraph from the graph we have. Okay? So again, if you have questions, raise hand lang. Okay. Next are the loops. Essentially, a loop is just a closed path. Okay? A path, you start from a node, and then you go around the network, and then if you end up at the same node, then you traverse a loop. Okay? Ang importante lang naman sa loop is that you do not go through a branch more than once. Okay? So say here, you start at node 1, you go around, you traverse or you pass through branches 1, 3, 6, and 7, you have a loop. Okay? This one is another loop. So 1, 3, 2, 4, and 5, you go through those nodes one after the other. In that order, you form another loop. Okay? You start at 5, node 5, you go to node 4, node 3, node 1, and then you go back to node 5, and that's another loop. Okay? And I think you agree with me that there are several loops for this graph. Okay. Moving on. For this graph, let us choose a tree. Again, a tree by definition. Let's go back to that slide. It is a connected subgraph. Again, it's a subgraph. It's a subset of the entire graph. Within all nodes are present. Okay? It contains all nodes, but do not contain any loop. Just like this one. Okay, this is a tree because this subgraph has all the nodes in it. Yung limang nodes, 1, 2, 3, 4, 5. However, we do not have a loop. Gusto dan mag-class? Okay, so I hope tumatango kayo with me, ano? Okay, so we do not have a loop here. So that's a tree. In fact, for that graph, you can draw maraming tree na mag-exist. Okay, so you could draw the branch here and remove this branch number 6. Let's say you draw branch number 2 and you remove branch number 6, that's another tree. Okay, or you could have say 1, 2, 3, and 6. Okay, so this branch, this branch, and also that branch. That is also a tree. Okay. Now notice that when we draw a tree, there's always 4 branches. Okay. Kasi if we add another branch here and remove this branch, what we get is a tree, and that tree has 4 branches then. Okay. So if we choose this one, and this one, together with that one, we have a tree, and that tree still has 4 branches. Okay? Now, if, so going back to the graph, this one, if we remove the tree, yung matitira, what's left with us, is called the co-tree. Okay? So if you put the tree and the co-tree together, what you will get is the entire graph. Okay? So again, that's the graph. You choose a tree. If you remove the tree from the graph, you are left with a co-tree. Okay? So the co-tree should contain all the other branches. Yung lahat ng branches that are not included in the original tree. Okay? So here, the co-tree is composed of branches 2, 4, 2, 3, and 4. Okay? So if you choose another tree, obviously there should be another co-tree. Okay? So for each tree, there is a corresponding co-tree. Okay? Now moving on. So let's say we have chosen the tree, this tree, and because and for that tree you have this co-tree, then for that co-tree, there are 3 fundamental loops. So again, going back, okay, so if you have your copy of slides with you, a fundamental loop is a loop. However, only one branch of that is a link. Okay? By the way, hindi ko yata na-define yung link. The links are the branches in the co-tree. Okay? So the links are branches 2, 3, and 4. Okay? So this is the co-tree. Okay? And if we choose link number 2, this is the only loop that we can draw. Okay? It's the only loop that we can draw that includes at most one link. Okay? So wala na kayong madodrawing na loop na si 2 lang, si branch number 2 lang ang link sa kanila. Okay, take note that in this loop, branches 1, 6, and 7 are parts of the original tree. Okay? Moving on, for link number 3, again, there's only one fundamental loop that you could that you can draw, and this is it. Okay? Yan lang. Okay? So 3, 1, 7, and 6. Kayo, no? Maybe later on pagkatapos ng lecture, maybe you can check. Okay? But I'm sure that wala na kayong mahahanap. Okay? And then for branch number 4 or for link number 4, this is the only fundamental loop that you can draw. Okay? So for our graph, okay, once we have chosen the tree, we will be left with a particular co-tree. And for that co-tree, for each link in that co-tree, there will be a fundamental loop. Okay. Now, the next thing that we will define is the cut set. Again, the cut set, it is a group of branches, a set of branches that divides the graph into two disconnected subgraphs. Okay. So this is our original tree. Okay. So imagine you get a knife and then cut it that way. Okay. So essentially we are cutting the entire tree into two disconnected subgraphs. This subgraph here and this subgraph here. Okay. The subgraph that consists of nodes 2, 3, and 1, and the other subgraph consisting of nodes 4 and 5. Okay. Now, the cut set, it is the set of branches that separates one subgraph from the other. Okay. So for this particular figure here, branches 3, 5, and 7, 3, 5, and 7, they form a cut set. Okay. At the bottom is another example. So let's say ito yung dividing line natin. Ano? We cut the entire graph between this node, a standalone or an isolated node inside, and these four nodes outside. Okay? And the cut set that makes that division is composed of branches 2, 4, and 5. Okay? So when we say cut set, it is a set of branches that cuts the graph into two disconnected subgraphs. Okay? Now, we have defined the cut set. So at this point, let us now define the fundamental, okay? The fundamental cut set. Okay, so what's the fundamental cut set? Fundamental cut set, again, we have to define a tree muna, no? So from the original network, this one, let us choose a tree. So ito, okay, so that's the tree. And the fundamental cut set is a cut set wherein only one branch is a tree branch. Okay? Only one branch is a tree branch. So meaning, if we're going to choose branch number 1, what are the other branches that will go with branch 1 such that those branches, when you remove that from the graph, you are left with two disconnected subgraphs. Okay? Although tinanong ko kayo, you can see the answer here. Okay? So this is a fundamental cut set because branches 1, 2, and 3 divides the entire graph into two disconnected subgraphs. This one and that isolated node 2. Okay? And the cut set is composed of branches 1, 2, and 3, and only one of them is branch number 1. Okay? So moving on, so if we want to get the cut set where 5, branch number 5 is the only element, then the cut set is this one, itong tatlong to, composed of branches 2, 4, and 5. Diba? Kasi in these branches, branch 5 is the only tree branch, while 2 and 4 are links. Okay? They are branches of the co-tree. Diba? They don't exist here. Okay, they're not here in this particular tree branch. Okay, and then 6, this one. What are the other branches that we can lump with branch 6 that will divide the graph into two disconnected subgraph? Ito, 2, 3, 4, and 6. Okay, and I hope you will be able to explain to yourself why branches 2, 3, 4, and 7 form another cut set. Okay? In fact, later on, makikita ninyo yung first homework natin. I'll give you a network, and then I'll ask you to get the fundamental loops, and then the fundamental cut sets. Okay? Questions, guys? Okay. Now, after defining all of those loops, fundamental loops, we have the graph, we choose a tree. The tree will have branches. If you remove the tree, you will get the co-tree. And then the co-tree, the branches of the co-tree are called the links. Okay? And then for the co-tree, you'll be able to get, for the co-tree, you will be able to get the fundamental loops. And then from the tree, you'll be able to get the fundamental subsets. Okay? Now, from there, we can now define the incidence matrices. Okay? So the incidence matrix, it's a matrix, okay? And it's a matrix that we use to represent the topological properties of a network. So when we say topological properties, think of it as how the different things in the network are interconnected to each other. Okay, so in a way that's the topological properties of the network. Okay, so we have a network. We can see that, okay, we see a substation here, a substation there, etc., etc. How are we going to represent the connectivity among the different substations using a mathematical expression? Okay, and one way to do that is to use matrices. Okay, and for this particular case, we're going to use an incidence matrix. Okay, now we use a matrix to represent the network topological properties because it provides ease and convenience in computer analysis. You know that it's very easy to, relatively easy to manipulate matrices. Uh, we can operate with matrices. You can write computer programs that manipulate matrices. Okay, so if we use a matrix to represent a network, then it's one step, okay, closer towards the analysis. We can now use a computer to analyze that. Okay, now to to define or to capture the network topology or the connectivity using a matrix, we can use several types of incidence matrices. Okay, so you could see here the three: the node to branch incidence matrix, the fundamental loop incidence matrix, and the fundamental subset incidence matrix. Okay, so at this point, we will just build matrices. Okay, we will just build matrices. Okay, so first let us define the node to branch incidence matrix. Okay, so basahin ko na lang muna to, no? For an oriented and connected graph G with n plus 1 nodes and B branches, the node to branch incidence matrix has a dimension n plus 1 rows and B columns, and will have elements of 1, -1, or 0. Okay? So essentially, we are using a matrix to describe the incidence of nodes to branches. Okay? And if a branch is not incident to a node, the entry is just 0. However, if a branch leaves a node, the entry is 1. And if a branch enters a node, the entry is -1. Okay? The node to branch incidence matrix is the following structure. Okay? So here, uh, these are the branch numbers. So take note, yung graph natin has 3 branches. So the first column will correspond to branch number 1, second column branch number 2. So this is branch number K, and that's branch B. Okay? And then the rows correspond to nodes. So the first row is node 1, node 2, node I, node J, and node n plus 1. Okay? Now, if we look at a particular column, say column K, which corresponds to branch K, we see that a branch is only connected to 2 nodes. Diba? Hindi ka pwede magkaroon ng branch na nakabit sa 3 nodes. Hindi na branch yun. Diba? Hindi na branch yun. A branch only has 2 ends, and on each end you have a node. Okay? So it means that for this column here, all the elements here will be 0, except for 2. Okay? What this is telling us is that branch K is connected to node I, and at the same time connected to node J. However, you have here a +1 and a -1. So you have a +1 if branch K leaves node I. It means that branch K is leaving node I, and branch K is entering node J. Okay? Sige, I'll give you an example in a couple of slides. Ano? Okay? Now, at this point, we see that the branches are arranged, okay, from 1 to B, so according to the branch numbering, okay. Now, if we rearrange the columns such that the first n columns rather, are the 3 branches, okay, and here the next columns are the links, okay. So essentially, we have the same matrix, we just rearrange the columns, okay. Wherein the first columns are the 3 branches, and then the last columns correspond to the links, okay. So that's how we construct the node to branch incidence matrix. So I'll give you an example at this point. This one, okay. This one here, okay. So the matrix is the block, the green block. Yung matrix natin yung green block, okay. So here for our graph, we have 7 branches, okay, and we have 5 nodes, okay. So here we can see that branch 1 is connected to nodes 1 and 2. In addition to that, branch 1 is leaving node 1, kaya positive 1 to, and it is entering node 2. That's why this is negative 2, a negative 1. Okay. Similarly, branch 2, okay, it is leaving node 3. Hence, we have a positive 1 here, and it is entering node 2, kaya may negative 1 tayo doon. And so on and so forth. Okay, so figure that out. Hindi ko na isa-isa yan, no? Yung 7 branches. But the main point here is that for each column, all elements will be 0. Hindi ko nilagay yung mga 0. Okay? All those blank spaces are zeros. Okay? Only 2 elements are non-zero. Okay? The row where you will see the positive 1 is the row where the branch is leaving the node, and you get a negative 1 if the branch is entering a node. Okay? Another way to look at this matrix is, let's say you look at node number 4, sorry, row number 4, and row number 4 corresponds to node number 4. And you will see there a 1, and a negative 1. What this is telling us is that branches 3 and 6 are leaving node 4, but branch 5 is entering node 4. So ito. So you have 3 and 6 leaving node 4, and then you have branch 5 entering node 4. Okay? Now, what we're going to do is we will choose node 5 as the reference node. Okay, one node here. Okay, so if the row corresponding to the reference node is removed, then the matrix is reduced to an n by b incidence matrix A. And the rows of A will be linearly independent. Take note, in this matrix, the rows are linearly dependent. Okay, and we don't need that. Okay, we have to have a set of equations that are linearly independent. And we can do that by choosing one of the nodes as the reference node and removing the row corresponding to that. So if we choose node 5 as the reference node, okay, then let's just remove row 5. Okay, tanggalin natin yung last row, and we are left with this matrix. Okay, and then the final step in the process is to rearrange the branches such that the first columns are the 3 branches, and then the last columns are the links. So here, we have chosen this 3. So the 3 branches are 1, 5, 6, and 7. So pipiliin lang natin yung branches 1, 5, 6, and 7. Iuuna lang natin sila. We put them at the left, and then these are the links. Okay? Branches 2, 3, and 4. So this matrix here, itong 4 by 4 matrix na to, that's the A sub T. It's a square matrix, and by n, 4 by 4. And A sub L is the matrix for the links. Okay? Questions? Okay. Hindi ko nakikita kami nag-raise ng hand. Okay. It seems wala naman. Okay. Sige. Let's move on. So at this point, we have defined an incidence matrix, the node to branch incidence matrix, because we can see the connectivity between the nodes and the branches. Okay. So the next one, another way to represent the connectivity the interconnection in the network is through a fundamental loop incidence matrix. Okay. Again, so this is another matrix. Okay. So we have a graph. We choose a tree. Okay. And then once you have chosen a tree, there will be a co-tree. And then the co-tree will have links. And then for each link, we will now derive the fundamental loops. Okay? So at this point, we will now get the incidence of the fundamental loops to the branches. Okay? So again, the elements of that incidence matrix is either 1, -1, or 0. Okay? Now, the columns are the 3 branches. Okay? So ganun pa rin, 1 to B. And then the rows, however, are the fundamental loops. Okay? They are the fundamental loops. Now, the element is 1 if the branch is in loop L. It has the same direction as the link. -1 if the branch is in the loop, but in the opposite direction. And 0 if the branch is not in the loop. I think it's easier to explain that through an example. Okay, like this one. Okay, so we are still using the same tree, same graph. Okay, same graph. And then for that graph, we have chosen this as the tree. And since that is the tree, ano yung co-tree natin? Yung branch 4, branch 2, and branch 3. So this is the co-tree. Okay? And then for that co-tree, we have 3 links, 2, 3, and 4. And for each link, there is a fundamental loop. Okay? So this is the fundamental loop for link number 2. This is the fundamental loop for link number 3, and the fundamental loop for link number 4. In fact, you have seen that earlier kanina. Okay? Nakita nyo na yan kanina. Okay? Now, let us construct the loop incidence, the fundamental loop incidence matrix. Okay? Again, the columns are the branches. Branch 1, branch 2, up to branch 7. And then we have 3 fundamental loops. Fundamental loop number 2, fundamental loop 3, and fundamental loop 4. Like so. So the first row here is fundamental loop 2. It corresponds to fundamental loop 2. And take note that fundamental loop 2 has 4 branches. Branches 1, 2, 5, 6, and 7. Parang mali yata ako. Sandali lang, guys. 1, 2, 5, 6, and 7. Parang na-miss ko yata itong 5 na to. Dapat yata may laman to. Nakita nyo ba, guys? Parang may mali ako. Ang ito lang nakita to. Sagot naman kayo sa chat to. Kahit yes. Okay? Essentially, what I'm saying here is that these are the branches that will belong to the loop. Okay? So for example, skip natin yung fundamental loop number 2. Say fundamental loop number 3, this one. Okay? So the branches that are there are branches 3, 1, 7, and 6. So 3, 1, 7, and 6. Okay? Now, how do we assign a positive 1 and a negative 1? Well, for example, here on this fundamental loop, ito yung link, okay, corresponding to that fundamental loop. Let's just go around the loop along the direction of that link. Meaning, yung direction ng link natin pataas. So let's just go around that loop that way. Okay? And we see that branch 1 is opposite the loop direction. Branch 7 is at the same direction, but branch 6 is opposite. Diba? So here, branch 3 rather, same direction, so positive 1. Branch 1 is opposite direction, kaya negative 1. Branch 7 is same direction, we are going counterclockwise, kaya positive 1 to. And then branch 6 is opposite the direction of the loop, kaya negative 1 siya. Okay? Similarly, let us look at fundamental loop number 4. This one. Kaya ko yata i-edit ko. Anyway. Fundamental loop number 4, the direction of the fundamental loop is also counterclockwise along the direction of branch number 4. And we see here that there are 4 branches. Branches 4, 7, 6, and 5. Kaya ang may elements lang dito, yung 4, 7, 6, and 5. Okay? 4 is along the direction of the loop together with branch 7. However, branch 6, when we pass through branch 6, parang opposite direction, and branch 5 is also in the opposite direction. Hence, we get here -1.
It's 7 o'clock.
-1. Okay? Dapat piniminto na ako. 7 o'clock na. Okay. May edit ko ba to? Wait lang guys. May edit ko siya. So, sino dapat yung kasama dito? 5. This should be -1. Agree, guys? Agree?
Yes, sir.
Yan. Hindi nawawala. Editable naman pala siya. Okay. Sige. Saan kayo na yung -5? So 5 dito, dapat may -1 din dito. Okay? So what I've done here at the bottom is I rearrange the columns such that the first 4 branches are the 3 branch and the last 3 columns are the links. So the links are branches 2, 3, and 4. Kasi lang nandun. The 3 branches are 1, 5, 6, and 7. So let's just jumble, rearrange the columns, and this is what we will do. Okay? Questions? Okay. Sige. Sige, I'll proceed. I'll try to finish by 7:30. Sabi ko, at most, this is gonna be. Okay? Now, so that's the fundamental loop matrix, incidence matrix. The last one is the fundamental cut set matrix. Okay? So for the fundamental cut set matrix, again, you have the graph. You choose a tree. And then after choosing the tree, we know that for each branch of the tree, there will be a fundamental cut set. Okay? There will be a fundamental cut set. Okay? And then from the cut sets, from the fundamental cut sets, we will now get the incidence, okay, of the branches to the fundamental cut sets, whether the branches are part of the cut set or not. Again, the elements of the matrix are just 1, -1, and 0. Okay? 1 if the branch belongs to the cut set and has the same direction. I'll tell you later what same direction means. -1 if the branch belongs to the cut set and opposite direction. And 0 if the branch does not belong to the cut set. Okay? Now we construct the cut set this way. The variable that we will use is Q. Okay? Again, the columns are still the branches, and then the rows are the fundamental cut sets. Okay? And the numbers 1, 0, and -1 is just the incidence, whether the branch belongs to the cut set or not, or whether the branch is at the same direction of the cut set or not. Okay? Let's proceed with the example. This one. Again, same graph. We choose the same tree. Okay? And then for this tree, let's choose branch number 1. And for branch number 1, we can only draw 1 fundamental cut set. Okay? Meaning, these 3 branches divide the entire graph into 2 disconnected graphs. Okay? Yan. Okay? And then for branch number 5, this is the fundamental cut set. For branch number 6, this is the fundamental cut set, and this is the fundamental cut set for branch number 7. You have seen that slide kanina. Okay, inulit ko lang. You'll see that these figures again on the next slide, together with the fundamental cut set incidence matrices. Okay? So take note that we have 4 fundamental cut sets. Okay? Kasi 4 yung 3 branches natin, and for each branch, you have a fundamental cut set. So you have 4 branches, 4 fundamental cut sets, meaning our matrix will have 4 rows. So it will have 4 rows. Okay? The first row is fundamental cut set 1, essentially this cut set here. And that fundamental cut set contains branches 1, 2, and 3. Hence, 1, 2, 1, 1, and 1 corresponding to branches 1, 2, and 3. So how would we know if we will assign a positive 1 and a negative 1? Well, branch number 1 is pointing that way, from this subgraph to that subgraph. And we can see that the other two branches, branches 2 and 3, are pointing at the same direction. It's crossing. It's moving from one cut set to the next cut set, one subgraph to the next subgraph in the same direction, okay? From left to right, from this side to that side. Hence, they all get a positive 1. So they will get a positive 1 if the branch has the same direction as the cut set. So in this case, the direction of the cut set is that way, from left to right, okay? Now let's move on to the next cut set, this one. The cut set has 3 branches, branches 2, 4, and 5, okay? Hence, for cut set number 5, yung may 1 lang dito is ito, branches 2, 4, and 5. And since this branch is going out, palabas siya, it's moving from inside to outside, okay? And the other 2 branches are doing the same thing. They're going from inside to outside. So they are at the same direction as the cut set. Hence, all of them gets a positive 1. Same is true for this cut set. Just figure it out. I would want to focus on the 4th one, okay? Here, this cut set here. Because branch number 7 is moving from the top side to the bottom side, okay? However, we see here that branches 2, 3, and 4, they are moving from the bottom to the top. They are directed from the bottom to the top. Hence, only branch 7 gets a positive 1 here, and the rest, branches 2, 3, and 4, get a negative 1. Okay, class? Okay pa tayo? Okay? Pag okay pa, thumbs up lang kayo sa ano, ha? May nakita ako nagtaas ng kamay at nagbaba ng kamay. Yes, please. Jojo?
Sir, yes, sir. Ask ko lang, sir, if pwede ba yung, yan na po ba yung cut set natin, sir? O pwede pa maiba yung form yan?
Ganito lang siya. Start with the 3. Okay, yung 3 natin yung kumpleto, ha? Once you have chosen a 3, you start from the graph. Okay, from the graph, you will choose a 3. Okay? Kapag pumili ka na ng 3, unique na yung makukuha nating cut sets. At dahil unique na yung makukuha nating cut sets, ito na yung 4 na fundamental cut sets na makukuha natin. Wala nang iba. Okay? Since these 4 cut sets are unique, it means that the cut set incidence matrix is also unique. Wala na tayong ibang makukuha. Okay?
Okay, sir. Thank you.
Okay. Sige. Thanks for asking. Nakapag-break ako para makain. Okay? Next. Okay, so those are the fundamental cut set incidence, fundamental incidence matrices. Okay? So take note that we have constructed 3 incidence matrices. Okay? The node to branch incidence matrix, this one. Okay? Node to branch, so the rows are the nodes, the columns are the branches. Okay, that's the first one. We call it A, matrix A. The left side is A sub P, the right side is A sub L. And then we have the fundamental loop incidence matrix. We call it matrix B. The left side is B sub P, the right side B sub L. Again, these are the columns corresponding to the 3 branches. These are the links, the columns corresponding to the links. And then, for the fundamental cut set, we will use Q. Rearrange it again. Actually, hindi ko pa yata sinasabi yung rearranging part. Rearrange them again. We see here that this is Q sub P, and then on the right side Q sub L. And take note that Q sub P is an identity matrix. Okay? So since that's an identity matrix, this matrix here is enough. Okay? It contains enough information to describe the topology of the network. So imagine, you have a 4 by 3 matrix, a matrix with only 12 elements, and it will tell us how this network is interconnected to each other. How many branches are there? Which branch connects one node to the other? Okay, using a matrix with only 4 elements, and each element can only take 3 values, either 0, 1, or -1. So take note, class, if we store that information, ang tipid niya, no? Kasi it's just a 4 by 2 matrix. We don't have to store that identity matrix. We know that it's an identity matrix, so we don't have to store it anymore. Okay? So if you're going to reconstruct, if you will reconstruct the network from that matrix, you just do the reverse. So you have that matrix, 4 by 3 matrix, you append to that the identity matrix, and then from the cut set, incidence matrix, and the branches, you can reconstruct the network. Okay? So I hope at this point you agree with me that if I give you a matrix, let's say I give you this matrix here, okay, itong B sub P, you should be able to reconstruct the original network. Take note that the right side is identity matrix. You don't have to store that anymore. Okay, so that's it's a 3 by 4 matrix. So we save some space, ano? Okay? As opposed to the branch to node to branch incidence matrix, we have to store the entire thing. It's a 4 by 7 matrix with 28 elements. Okay? So medyo malaking space yung kailangan natin to store the information. Okay? So that's the advantage of the fundamental loop and the fundamental cut set incidence matrices. Okay? So mas complicated lang yung pag-derive. However, we can they save space. We need fewer elements to describe the network. Okay? So at this point, we will now define the relationship between the three matrices, A, B, and Q. Actually, ito yung part na mahirap to explain. So what I'll do, I'll just ask you to just verify this. For this network, for the network that I gave you, alam na natin yung matrix A. And matrix A, you can divide that, you could slice that into two. The left side would be A sub P, the right side would be A sub L. Okay. You can confirm that A times B transpose will be 0. Okay. So, yung A natin is this matrix here. This is the A matrix. Tama ba? No, that's the fundamental. No, that's not that. That's this one. This is the A matrix. Okay, that entire thing. If you multiply that to B transpose, can si B transpose, itong matrix na to, this thing here, you multiply that to B transpose, you will get a 0. Okay? So that's one important identity. You don't have to memorize that, but what you can do at home is just verify. Okay? So, an important relationship that you'll be able to establish is this one. Actually, parang FYI na lang to, no? Okay, because of that equation, you will be able to confirm this. Okay, no need to derive, just have to verify. Okay, another important relationship is Q times B transpose is also equal to 0. Okay, and take note that if you get the transpose of both sides, you will get a B times Q transpose. Okay, that's also equal to 0. Okay, and since the B matrix is this one, B sub P, and this is B sub L. B sub L is identity matrix. And then Q naman, you have Q sub P here, okay, and then here you have Q sub L. But Q sub P is also an identity matrix. Okay, so if you multiply them, and then after a few manipulations, this is what you will get. Okay, B sub P is equal to the negative of QL transpose. In fact, we can verify that, okay, in the previous example. Okay, so this is Q sub L. If you transpose that and get the negative, it is just equal to this matrix here. Okay? So you can confirm that. So this is B sub T. You get the negative of that, and then you transpose it, you will get this matrix. Okay, guys? Now, at this point, let us write Kirchhoff's laws using the incidence matrices. Okay? So let's say that we have a graph. Wait lang, ha? I'm just looking at how many slides do I have there. Ang dami pa pala nito. Okay. Sige, I'll try to do this in 15 minutes. Lilipad tayo. Okay. So, at this point, let us use the incidence matrices to write Kirchhoff's laws. Okay. We have a graph with n plus 1 nodes and b branches. Okay. Take note that the number of independent nodes equal to the number of 3 branches. So kanina, no, yung example natin, we have 5 nodes in total. We remove 1, so naging 4 na lang. So those are the number of independent nodes. And when we drew the branches, we draw the tree has 4 branches left. And for each branch of the tree, there is a cut set. So that's also equal to the number of fundamental cut sets. Okay? The number of fundamental loops is equal to the number of links. Okay? And yeah, yun lang. Kasi for each fundamental loop, there's one link corresponding to it. Okay? You can confirm this in the previous examples. Okay? Now, ito, definitions lang to, no? I think the best way to do it, this is through the example na. Okay? So here we have a graph. That graph has 5 nodes again, okay, and 7 branches. We have 4 independent nodes, okay, and that's equal to the number of 3 branches, the number of cut sets, okay. Now, if we assume that node 5 is the reference node, kumbaga siya yung ground na reference, then we have 4 voltages, V1, V2, V3, and V4, okay. V1 is the voltage from node 1 to node 5. V2 is the voltage from this point to that point. Voltage from node 2 to node 5. V3 here is the voltage from node 3 to node 5. And V4 is the voltage from node 4 to node 5. Kumbaga, V1 to V4 are the voltages at the nodes with respect to node number 5. Okay? So that's V sub n here. Now, I sub B naman, these are the branch currents. Okay? So, the current going from this point to that point, that's I1. Nasaan si I2? This current. We will follow the direction of the arrow. I3 is that one, I4 is the one going up, I5 is the one going down, etc. etc. Okay? So, take note that we define lang tayo ng terms. Okay? Now, let's say we have that graph, okay? We have this node voltages. Now let us define the branch voltages. So what are the branch voltages? Yun yung voltage across each branch. Okay? So the voltage across branch 1 by KVL is V1 minus V2. Agree? The voltage across branch 2 is V3 minus V2. So take note, since the current is going that way, the polarity of the voltage that I am using is, this is the plus, this is the minus, okay? So the direction of the current is going from the plus end of the voltage to the negative end of the voltage, okay? So the voltage across branch 2 is, andito yung plus, andito yung minus. For branch 3, andito yung plus, andito naman yung minus. Okay? And now we can write the branch voltages. Okay? So V12 is V1 minus V2. V34, the voltage across branch 5, ito yung branch 5, is V3 minus V4. The voltage at branch 6 is V4 minus V5. And the voltage across branch 7 is V1 minus V5. Like so. Nasundan ba guys? Okay. Sige, tingnan ko lang yung sa diba. Yung nag-raise ng hand. Okay. Now, for that particular graph, let us choose a tree. So let's choose the same tree. Okay. For this tree, the link currents are I2, I3, and I4. Kasi yung mga links ay yung branches 4, 2, and 3. So yung currents doon sa branches na yon, yun yung mga link currents. I2, I3, and I4. Okay? Now, V sub T are the 3 branch voltages. So take note, that's the tree, and the tree has 4 branches. And the first row here is the voltage across branch 1. Kaya V1 minus V2. The second row, that's the voltage across branch 5. Kaya V3 minus V4. Similarly, this is the voltage across branch 6. Kaya V4 minus V5. And lastly, the voltage across branch 7. Kaya V1 minus V5. Okay? So, again, when you see V sub n, that's the voltage from the node to the reference. If you see a subscript of B, we are referring to the branch. Okay, to the branch. Okay. When you see a subscript of L, we are referring to the links. When you see a subscript of T, we are referring to the tree. Okay. So if you see a subscript of L, we are referring to the links or to the co-tree. Okay. So, ang dami-dami natin pinagdaanan, and we will just represent KCL and KVL that way. Okay? But before that, the branch currents is this. It's just the union of the currents on the 3 links, 3 branches. Ito yung currents, the 3 branches. Ito yung mga currents dun sa links. Okay? Now, VB, these are the branch voltages composed of the voltages at the 3 branches and the voltages of the links. Okay? Now, that's I sub B, B sub B, KCL is written that way. Where capital A here is the node to branch incidence matrix. Okay? Nai-imagine nyo ba guys kung paano naging ganito ang equation na to? Recall the node to branch incidence matrix. If you look at each row, for each row, we are indicating which are the branches connected to it. Okay? And then, we also indicate whether a branch is entering or leaving the node. And if we multiply that particular row with the branch currents, then we are simply saying that all currents going in is equal to the sum of all the currents going out. Or the sum of all currents going in and all the currents going out is equal to 0. Okay? And we just assign a negative sign to all currents going out. Okay? Diba? And then similarly, B it's the fundamental loop. Take note, we have a loop. And then as we go around the loop, we will see branches that are along the direction of the loop or opposite the direction of the loop. So if we multiply a particular row in the B matrix with the branch voltages, then we are simply doing a KVL. Okay? I think the best way to do that is let's go to the example, to the incidence matrices. Okay, like this one, this one here. What this is telling us is that okay, I1 plus I7 minus I4 is equal to 0, diba? Negative I1 minus I2 minus I3 is equal to 0. And then I5 plus I2 plus I4 is equal to 0. So that's our KCL. Okay? And then for the KVL, let's use this. The fundamental loop. Ang sinasabi nito, the voltage at branch 1, we're looking here, no? Let's go around in a counterclockwise fashion. Negative of that voltage plus this voltage plus the negative of that voltage plus the negative of that voltage plus that voltage is equal to 0. Okay? So the only ones getting a positive are 7 and 2. So that voltage and that voltage, plus minus, plus minus. Okay? And then you add to that the negative of this voltage, plus minus, the negative of this voltage here, plus minus, and the negative of that voltage, plus minus. That's the KVL. Okay? If we follow along row number 1. Okay? So, dami-dami nating pinag-usapan, and we are simply explaining KVL that way, okay, and KCL these ways, okay. These are other expressions for KVL and KCL, okay. This is another expression for the KVL here, okay. So essentially, it's just a relationship between the node voltages and the branch voltages, okay. Plug in from this equation here, we can derive that. So this is another expression, another relationship between the 3 voltages and the link voltages. Ang sinasabi lang nito is that once you have the 3, you can derive from the 3 voltages all the link voltages. Okay? I hope you, ang hirap nang i-imagine, ano, but it's something that you can figure out. Okay? I think ito. Okay? So if you want to, I hope you will agree with me that the voltage across this link can be written in terms of the voltages on those branches. In fact, the voltage across that link is just equal to this voltage here plus that voltage there. Diba? The voltage between this on this link, this is a link, ano? Yung branch na nandyan, link yan. The voltage across that is just equal to this voltage plus that voltage plus that voltage. I-consider na lang natin yung signs. Okay, yun lang yung sinasabi nito equations na to. You can relate the link, the voltages on the links to the voltages at the trees. Okay? You either use the B matrix, B sub T matrix, or the Q matrix transpose. Okay? Question, guys? That's KVL. And then there are other expressions for KCL then. Like this one. Okay? Here we can relate the link currents to the branch voltage currents. So going back to the same equation. Paano natin how are we going to relate the current here with the currents on the trees? Well, the current here is equal to this current plus that current. Diba? For this link, the current there is equal to this current plus that current. Similarly, the current here is equal to this current plus that current. And lastly, the current here, paano natin kukunin yung current na yon? In terms of I1, I5, I6, and I7. Okay, so we have I2 going that way. How are you going to express I2 in terms of I1, I5, I6, I7? I leave it up to you guys. Okay, figure that out. Okay, hindi obvious dito, pero I think you can figure it out. Okay? That's the last equation here. Okay? And then there are other expressions as well. Okay? 7:28 na, time check lang tayo. May promise to use. I'm going to end this by 7:30. Actually, I think I can end this now because for the rest of the week, I would like you to study on your own the path to branch incidence matrix. Okay, the definition is already here. Okay? Meaning, based on the definition of the incidence matrix, they are defining it here, the elements can either be 1 or 0, you are now going to derive this incidence matrix for this particular network. Okay? So, again, kung paano natin define yung ibang incidence matrix at kung paano natin kinonstruct, it's already given here. I'll leave it up to you. Okay? So, your goal here is uh, to explain to yourself, convince yourself that this is the path to branch incidence matrix. Okay? Hindi na ako mag-elaborate. I think by going through this, by reading all of these two slides here, I think you can figure this out. Okay? And then we will now have another incidence matrix, the P matrix. Okay? Again, we will rearrange that such that the first the first columns will be the three branches. Okay, so here you have a network. It's a different network, by the way, guys. It's a different from what we've been seeing so far. Okay, so for this particular network, we will define a tree. Okay, and then for that tree, these are the three branches. I think 1, 2, 3, 4, 5, 6. And then meron tayong links, dalawa, yung 7 and 8. Those are the links. Okay, essentially, each row corresponds to a path. It's a path from each node going to the root of the network. Okay, so usually for a distribution network, take note, this applies to a distribution network, a radial distribution network. We have a substation, okay, and everything is connected to that substation upstream. Okay, so like this one. Okay, and then as you go from a node, particular node to the substation, you just have to identify which branches you are passing through. Yun na yung incidence matrix natin. So please go through that. Okay? And then, here is an additional slide. It's a slide that relates the B matrix to the T matrix and the identity sorry, this I think is this is the identity matrix. Sorry, these are currents. Okay, these are currents. Okay, the relationship between the but this is the identity matrix. So A times T transpose is equal to the identity matrix, and then another set of equations that relates the B, the A, and the T matrices to each other. Okay. Now to conclude, guys, I think this will be the last slide for the evening. Meron pa akong additional slides, but I think it's better to do this sometime else when we are talking about the node the bus admittance matrix. Because I'm simply introducing here the building block method. What I'll do is I'll just transfer this set of slides when we go there. Okay, when we talk about the bus admittance matrix. Okay. So here I am giving you this this network. Okay, this network has 6 nodes and 7 branches. Okay, and I already have chosen the tree for you. Okay, yung dark, yung bold na branches, yun yung tree natin. Okay, so take note that for this node, for this network, we have 6 nodes. Okay, it means that n is equal to 5. Okay, so the total number of nodes is equal to n plus 1, hence n is equal to 5. Okay, so if we draw a tree, then the tree will have 5 branches. So 1, 2, 3, 4, 5. If we remove that tree from the network, we are left with the co-tree composed of branches 2, 5, and 8. Now for this particular graph and tree, I want you to get the node to branch incidence matrix, the fundamental loop incidence matrix, and the fundamental hot-set matrix. Okay. Now, how do you submit? I'll give instructions by email. You don't have to type everything. I know that it's tedious. Like type yung mga matrix and everything. You can write everything on paper. You can take a picture. As long as when you submit the pictures, you have to compile it into one file. Okay, maybe gawin yung paste sa Word para maging isang PDF file. Please do not submit 7 files for 7 pages. Okay, I'm only expecting one file for each person. Okay? And then at the UBLE, I will set up a submission bin. Okay? So, pag nag-login kayo sa UBLE, may submission bin doon for homework number 1. So, when you click that, papasok kayo doon and then you will upload the file. Okay? So, when you upload the file, andun yung pangalan ninyo, alam ko na kung sino yung nag-submit, may timestamp na rin, I would know kung kailan kayo nag-submit. Okay? So, again, the submission bin will be at UBLE, and this is your homework for the entire week. Okay? Part of the things that you will do for the entire week is to study the path to branch incidence. Okay? Any question, guys? Okay. Yes. Sino yung nagtaas? Nawala.
Okay, okay.
Wala. Yes lang. Okay. Wait lang ah. Wait lang. Sige, fire away.
Sir, regarding sa submission,
Sa,
wala pa kasi akong UVLE, nagre-request pa ako ng Billnet account.
Mhm.
So,